3 by 3. Good. What about number 2? 0. Correct. Number 3. Correct. 15 is correct. Number 4. 3 is correct. All right. And for number 5, which rows stay the same? Rows 1 and 2. Good. So what is row number 3 going to end up being? Remember, fractions only, please. So we got 4, negative something or other, and then positive something or other. So 29 over 2 for that third element. Yeah, I agree. And what was that middle element? See, a lot of you haven't done the work yet for it. So let me show you what I got to save time. All right, you should have got 4, negative 5 over 2, and then 29 over 2. And then here's the work. I did show my work on how I got that. Remember, it's row 1 minus 1/2 times row 3. So, 4 minus 1/2 times row 3. So that means negative 1 minus 1/2 times 3, and then 15 minus 1/2 times 1. So yeah, there's the setup, and then you just do the work, right? And assuming my math right, negative 1 minus 3/2 is, well, I showed it by hand, but you would just type this in, right? Negative 1 minus 3 over 2, hit enter, you'll get negative 5 over 2. Same thing for here. You would type in 15 minus 1/2, hit enter, you get 29 over 2. Remember, we want reduced fractions. We want either reduced proper fractions or reduced improper fractions. We never want mixed numbers. We don't want decimals. All right. So let's go into today's lesson. All right, row echelon form. We'll be doing specifically with reduced row echelon form. And these take a lot of steps, a lot of basic math. All right, you need lots of paper today, pencil, calculator. And of course, we need to know Friday's lesson. We need to know how to use performing row operations. We definitely need to know how to do that. So that was Friday's lesson. Again, today is Monday, September the 20th. This is day 2 of our 2.02. Okay, so some background info. So writing an augmented matrix. All right, so we're given the systems of equation here, right? We got 3 equations, right? 3 unknowns, x, y, and z. And we want to write this in matrix form. So pretty easily done. Every x, y, z, every variable has its own columns. We have an x column, we have a y column, we have a z column, and we have a equals some constant column. So if you notice for the first one, we have x, y, we're missing a z equals a number. So we have our negative 2x, we have our negative 4y, we have our plus 0z, and then equals a negative 10. That's the first equation. The second line, we have our 1x, 3y, negative 5z equals our negative 16 constant. That's our second equation. And the third equation is our third line, our third row. We have a 3x, we have a 2y, we have a negative 1z equals negative 6. So I put this vertical dashed or dotted line just to show that's their equal sign. When you actually create your matrix, you don't actually put this dashed or dotted line to show that. You would just have a 3x4 matrix written out. All right, so how are we feeling about writing the augmented matrix given, a systems of equation? Pretty straightforward, right? Nothing really difficult about it. Remember, we need placeholders, right? Placeholders. And then, make sure that before writing the augmented matrix, it has to equal a constant. So let's say if this was on the other side here, we would have to move it to the right. So make sure it does equal a constant, equal a constant, equal a constant before writing it in this augmented matrix form. That's really the only caveat. And of course, make sure everything is in order, X, Y, Z. All right, so let's quickly just practice this. It's pretty simple, right? So let me give you all 30 seconds to just go ahead and do number 1 and 2. We'll do 45 seconds. All right, what is the row of number 1? First row. One negative 311. All right, what about row number 2? Yep. Pretty simple stuff, right? All right, what about number 2? What is row number 1? Negative 5, negative 2, negative 3, and then 5. Yep. What about row number 2? Yep. Negative 1, negative 5, negative 1, 21, and the difficult row, row number 3. No, it says 0, negative 3, 1, and 8. Anybody else want to agree or disagree with that? Same thing? Okay, good. Yeah. Pretty easy, right? Pretty easy. Nothing difficult. Okay, now the fun stuff. The fun stuff begins. So row echelon form or we're actually doing reduced row echelon form. So whenever you see like in a textbook, they say row echelon form or they say reduced row echelon form, they are actually different. Your module uses the word or the words row echelon form, but they're actually talking about reduced row echelon form. So it's kind of a module mistake in verbiage. Yeah, I don't know why they do that. But anyway, RREF for short. So we'll be doing reduced row echelon form. Characteristics of reduced row echelon form. One, we have ones in the diagonal starting the top left. So if you notice here, we have one starting top left and then working our way in the diagonal. Look, 1, 1, 1. So there is the first characteristic. The diagonals must be all ones. The second characteristic of RREF is everything else that's above or below the ones have to be zero. So look, here's this one, we have zeros below it. Here's this one, we have zeros above and below. And then here's this one, we have zeros above. Now, the last column to the far right, these can be anything. Absolutely anything. We only care about, what's in the diagonal. So the diagonal reaches from here to here. So we only care about this square, this 3 by 3 part. All have to be ones in diagonal. Everything else must be zeros. Those are the two characteristics of reduced row echelon form. Your last column could be anything. Now, when it's in this form, this gives you the answer. So going back to these equations here, right? By creating this augmented matrix, we're setting it up to solve. Can you imagine trying to solve this 3 variable, 3 unknown by methods we learned maybe in Algebra 2, Algebra 1? Probably not very fun. Well, we're going to use matrix, the row operations, to actually solve for x, y, z. Now, once it's in this form, this tells us the answer. Think about this. This is 1x, right? 0y, 0z equals a 3. So class, what does x equal? Once we're actually in this form, what does x equal? If you were to rewrite this back into equation form, what does x equal? It's not 1. X equals 3, yeah. So look at this. So remember, this is 1x equals 3. This says 1y equals -2. And this is 1z equals 4. So this tells us x equals 3, y equals -2, and z equals 4. In coordinate form, it would be 3, -2, 4. That would be the order triplet form, x, y, z. Yeah, if we were to graph it, it would be a 3-dimensional graph, right? We have 3 variables. We have your 2-dimensional x, y, and then you have your z, right? Your z-axis. All right, is it clear how x is 3, y is -2, and z is 4 based on this form of the matrix? And that's the whole point of getting to this, to the RREF form. It gives you the answer to our system of equations. So you're probably wondering, well, how do we actually get here? Well, lots of row operations. All right, so here's some, I guess, general rules to follow when trying to use row operations to get here. All right, no really particular order here. So first one says only use row operations described in the previous lesson. So remember we can switch rows. We can have scalar multiplication, and we can add or subtract rows together. So everything we did on Friday, those 3 operations, we can either swap rows, use scalar multiplication, or add and subtract rows together. Those are the only 3 things we can do. All right, in the column on the left, start with the 1 and then finish with zeros. then move to the next row. So you can follow this. I think I pulled this from the module. And then finish by making zeros above the diagonal. So, in other words, let's look at an example because, seeing would actually make more sense, right? So first step is we're going to rewrite this equation in the augmented matrix form. So everyone on your paper, do that. And we get this. So every problem that we do is unique. There isn't just like a cookie cutter. This is what you do every single time. First step, second step, third step. You actually have to think for yourself and figure out this puzzle of how to get it in the form, right? So we always want to try to get your top left to be a 1. We want the row 1, column 1 element to be a 1. Now we have many choices. So looking at this matrix we created, what's something we could do? We can switch the rows. Remember, we can do 3 things, right? We can swap rows, we can use scalar multiplication, or we can add or subtract rows together. Those are the only three things we can do. So if you're thinking, oh, just subtract 4 to this, entire row here, you can't do that, You can't just subtract 4 from a row, it's not allowed. It's not one of the 3 operations, remember? So again, we can swap rows, scalar multiplication, or add rows together. All right. So it looks like Lilani says switch them. So she noticed that we have a 1 here, but if we swap row 2 and row 1, we'll then have a 1 in the top left. And that's what I did. Could we have also multiplied row 1 by 1/5? Would that have worked? Yes, it would have. Is that probably the best choice? Why or why not? Yes, because we would have fractions. We could do it, but it wouldn't be a great choice because now we're going to have fractions. So if you can think about this, right? 5 times 1/5 is 1. 4 times 1/5 is 4/5, and then -5 times 1/5 is -1. So we're going to have a fraction. That's not wrong. We're just, generally speaking, people don't like dealing with fractions. And if you can avoid fractions as long as possible, try to. Sometimes you can't avoid it. But yeah, so we want to swap row 1 and row 2. Your paper, go ahead and do that. And I'm going to show the work for that first step. So to the left of it, like in your module, they show the operation below the matrix. I show it to the left, partly because just to save room. So we swap row 1, row 2. All right. Perfect. Now we have a 1 here. So now this is what I do. When I have a 1 where I want it to be, in this case, top left, I am now going to make everything below it a 0. I'll make everything below it a 0. So we're going to use addition, subtraction of the rows to make that a 0. So think about this. How can I add these 2 rows together to make this a 0? Go ahead and write the operation we're going to do in chat. Like, for example, are we going to do row 1 plus row 2? Would that make it a 0? So let's think of it this way. All right, so we got, so somebody put row 1 minus 1/5 row 2. Okay, that would actually work, right? But here's the thing, 1 minus 1/5 times 5, yeah, you get 0. But then you get -5 minus 1/5 times 4. So now look, we're going to have fractions again. So, so Noah, what you chose is not wrong. However, we're now creating fractions. But that's okay. Like if you wanted to try to continue down that rabbit hole and do it that way, like you will probably, assuming your math is going to be right the entire, start to finish, there's nothing wrong with that. But really, we really kind of want to try to avoid fractions if we can. I wouldn't say fractions ruin everything. I think just it makes things look more difficult than it really is. So we're going to use this, and we're actually going to multiply row 1 um, by by a number. So think about this. You know, what times 1 added to 5 will give us 0? So yeah, so -5, right? -5 times 1 is -5, and then -5 plus 5 is 0. So that's what we're going to do. We're going to do that operation. And this is basically how every problem is going to be. Once we get a 1 here, you will always multiply that row times the opposite of this number. So because we want to make it a 0, we multiply 1 times, well, opposite of 5 is -5. So -5 times row 1 plus row 2, right? Remember, the second row is the whatever's listed second in the operation gets changed. So that we're not changing row 1, we're only changing row 2. Right? So I'm just going to copy row 1 down. Remember, we're not changing row 1. We're only changing row 2. And I went ahead and I showed the math, right? So we're doing -5 times row 1, which is 1, and then add it to our current row 2, which is currently a 5. Our second column in row 2 is going to be, again, -5 times row 1, which is a -5. We're going to add it to the current row 2. And then we'll do a -5 times row 1 again, and we're going to add that to row 2. So, all of you should probably write it out like I did. Maybe you feel comfortable of just doing it in your head, right? -5 times 1 plus 5. -5 times -5 plus 4. -5 times -1 plus -5. But I think writing it out probably is a way to not make mistakes, right? All right. So once you do the math, class, what is our row number 2? Once we simplify that, what do we get? What are those 3 elements? 0, 29, and 0. Yeah. All right. How are we doing so far? By the way, this is going to be one of your TGAs. So it's actually number 1 on your TGA is you need to use row operations to solve. And yeah. And really, you guys, these just take a lot of practice. Once you know how to do them or approach them, they're not that bad. All right. So look at this. We now have, of course, our 1 in the top left, and that's what we start with. We want to make everything below it a 0, which we did. All right. Column 1 is done. Next, we go to column number 2, and we want to make this, our goal now is to make this a 1. That is our goal. So any ideas of how I can make this a 1 using row operations? So yeah, we could divide the entire row, or in other words, right, multiply by 1 over 29, scalar multiplication. So yeah, Lalani, you can think of it that way. But the real way of looking at it is multiplying by 1 over 29, right? Row 1 doesn't change, and so 0 times 1 over 29 is still 0. 29 times 1 over 29 is 1, and then 0 times 1 over 29 is 0. Still feeling good? Everything's making sense? Yeah, good. All right, some of you are tabbed out and not paying attention. And this is one of those lessons that really, if you're not paying attention, you're not going to understand how to do any of it. All right. So, again, to kind of recap what we did so far, we made the top left a 1. We then used that to make everything below to 0. So column 1 is done. We now go to column 2. So the next diagonal would be this one. So we make that a 1 by using a scalar multiplication by multiplying that entire row by 1 over 29. That's a 1. So now, once that's a 1, we make everything above it or below it a 0. So we're going to use this 1 to make that a 0. So what is the row operation that we're going to do? How are we going to use this 1 to make that a 0? It is scalar multiplication. So what is the actual operation written out we're going to do? So it looks like Noah says 5 times row 2 plus row 1. I would agree with you. I would agree with you. Which makes sense, right? Because 5 times 1 is 5, plus -5 is 0. So yeah, that works. So 5 times our row 2 elements plus our row 1 elements. So row 2 is not going to change, right? 0, 1, 0. Only row 1 is changing because it's listed second in the operation. So we're going to do 5 times 0 plus the current row 1, 5 times 1 times the current row 1, and then 5 times 0 plus our current row 1. And I went ahead and just, wrote that out, right? So remember, 1, -5, and -1 are the current row 1 values. So again, we're doing 5 times row 2 plus row 1, 5 times row 2 plus row 1, and our 5 times the 0 plus our row 1. All right, once you do the math there, what do we get for row 1? 1, 0, -1? Yes, and we're done. So look at this. We got 1s in the diagonal. See that? 1s in diagonal. Everything above and below those 1s are 0s, right? So below that 1 is a 0, above that 1 is a 0. So this is in RREF form. So looking at this augmented matrix, what is the solution in ordered pair form? X comma y. What is the answer? -1 comma 0. Yeah, that's correct. That's correct. So on your TGA, you're also going to have to not only show this work, right? Write the answer in the RREF form, like I have highlighted in yellow, because this is, the question says find the REF for each of the systems of equations, which we did, but I'm taking it one step further and also writing the ordered pair solution. So, how can I check to see if negative 1 comma 0 is correct? No, the worst it's going to get is 3 rows, 3 row matrix, and that's what your TGA is going to be, is only 3 rows. Yeah, we're going to plug it in. So if we plug in -1 for x and 0 for y, it would work, right? 5 times -1 is -5, plus 4 times 0 is -5. -1 minus 5 times 0, so yeah, -1. Yep, plugging this in works for both equations, which means this is a correct answer. And that's how you would check. So on your TGA, once you actually have your order triplet x, y, and z, you would plug all the values back into all of the equations to make sure it works for every equation. And if it does, you know you have the right answer. All right, so let's recap this problem of what we did. All right, we rewrote the problem in the augmented form. We then look at this and say, hey, how can we make the top left number a 1? That's our first goal. And if you thought, hey, just multiply the row 1 by 1/5, yes, you could have done that, but it would have made fractions. Let's try to avoid fractions if we can. Sometimes we can't, but let's try to avoid them. And hey, look, there's a 1 right there. Let's just swap row 1 and row 2. So that's what we did. All right. Goal 1 is done. So maybe on your notes, you should put like first goal, top left, make the element a 1. Make, a sub 1, 1 equal a 1. That's our first goal. Once it is, our second goal is to make everything below that 1 a 0 by using row operations. So, once that's a 1, just multiplying it by its opposite in this case, like we did, and then adding it to that row 2 will make that so. So, once we make everything below that 1 is 0, column 1 is done. All right, so goal number 3 is to find the other diagonal 1. All right, so that's a 1. Diagonal from that is here. So we want to make this a 1 somehow. Generally speaking, we're going to multiply it by its reciprocal, which is what we did. So multiply that entire row by the reciprocal of that element, which is 1/29. Sometimes when we do this, this is where we're probably going to introduce fractions a lot of the times. But there are some things that we could also do to maybe avoid that in that scenario. It's kind of up to you. Like we don't actually have to make this a 1. We could have tried to kind of focus maybe on this and make that a 0. Every problem is different. So we'll just kind of have to see as we go, right? But we made that a 1, and then once that's a 1, our fourth goal is to make everything above that or below that a 0. So kind of the same thing we did up here. Multiplying this by the opposite. So multiplying row 2 by 5 and then adding it to the row 1, and that kind of finished the problem up. And whenever you have only 2 equations or 2 variables to solve for, the problems they're pretty short. They really are. Like we used 1, 2, 3, 4. We used a total of 4 row operations to get to the answer. And I'm going to say, generally speaking, that will probably be true for every problem that you are only solving for 2 variables. You'll probably only use 4 row operations to finish the problem. If we have 3 variables and 3 equations, that number will jump from 4 operations to probably 9 operations, 9 row operations, which we'll do one today if we have time. All right, we got about 20 minutes left, so let's go on to this one here. right, so number 4. All right, so this one also takes 1, 2, 3, 4 row operations. And it could be more. It could be more. So let's kind of work this one out together. All right, everyone should have written out the augmented matrix, right? So one thing that you could try, remember every problem is different. If we notice this is a 1 and this needs to be a 1, we could actually swap these two rows together and then multiply, when we swap it, multiply that row by -1, and that will give us a 1 here. And then you can work on getting the numbers above that 1 a 0. So that's one way to approach it. We don't have to make the top left a 1 first. It's as long as you use row operations, use them correctly, it doesn't matter. So we could have started a 1 here. That's not how I did it, but if you wanted to, you can. Let's do this. I'm going to give you all. Ooh, let's see what you can do in a minute and a half. See where it takes you. Remember, these problems can be approached very differently. So however you do it and how I do it could be way different. I do it in 4 operations. It might take you, this one could actually easily take 6 to 8 row operations. All right. Was anybody actually able to finish this problem, you think? Let's do a poll. Anybody able to actually finish this one in a minute and a half? I'd be really impressed if you could have. So some of you said, heck no. Some of you said, well, I got pretty close, you think, but nobody's able to finish. Yeah, I think a minute and a half is probably way too fast. Yeah, these problems do take quite a bit of time. All right, anybody like to share what you did first? Remember, there's more than one right answer what you could have done first. What does people do? So you switch row 1 to row 2, then multiplied row 1 by, yeah, so I did what Noah did. Yeah, that's what I did too, Noah. And I did it, so I use it as 1. So this is what I did. I swapped the 2 rows, but when I swapped them, I did what Noah did. So you may have done this in two lines of work. I just did it in 1. I swapped row 1 and row 2, but when I swapped them, I multiplied that row 2 by a -1/2 scalar. So I didn't talk about this on Friday, but we can combine, these 3 operations, like we can combine it into 1, right? So we did swapping and we did a scalar multiplication in 1 step. So this is okay, like on your work for your TGA or your quiz or your test or whatever, your work, you can do this. It's okay. If you don't like showing, these two things together, just separate them, right? So like Noah says in chat, it just, it saves a little bit of writing, right? All right. So no, good choice on what you did. Good choice because it's what I did too. But remember, there's more than one thing we could have done. Doing it this way allows us to avoid fractions, right? So try to avoid fractions. You don't have to avoid fractions, but this is probably the easiest, I think, that I thought of. All right. What's our next step? What's our next operation? -4 times row 1 plus row 2. We're trying to get everything below that 1 is 0. All right, what's our next step? Yeah, 1/7 times row 2. I would agree. All right, what's our final step? What's our last row operation we need to do? Remember, our goal is to make the numbers above this 1 a 0. So 2 times row 1 plus 2 times row 2 plus row 1. Yeah. I feel like only Noah is still with me. But yeah, there's the work. You do the math and you get the answer. So that means our ordered pair is 5, 5. X is 5, Y is 5. We can plug those in and we can check, and they do in fact work. All right, so we got about 12 minutes left. I do want to show you a 3x4 matrix because you will have your TGA, your first one on your TGA will be a 3x4 matrix, and it takes about 9 operations to solve. So I do want to show you. Okay. By the way, I took this directly from your module. So in the in the Learn module, they do this exact problem. Now, the way the module approaches this problem and the way that I'm going to show you how to approach this problem are very different. I saw their work and I'm like, well, I don't know, how they did it. I wouldn't agree with it being the easiest. So the way that I'm going to do it, and I'm going to show you the same problem, I'm doing differently to get the same answer. And you can decide if you like the way that I'm showing the work versus the way that they showed the work, or maybe you want to rework this problem and see how you would approach it. Remember, these problems can be done so many different ways. It's not a one way to solve. There's multiple ways to approach these problems. All right. So our first goal is to obviously write it in an augmented matrix form. And again, your TGA for this unit, you will have to do one of these 3x4 matrices. All right. All right. So at quick glance, what should we do first? I think maybe only Noah is with me, right? Actually, let's see who's still actively paying attention and taking notes. Okay, so actually quite a bit of you. All right, so out of those 8 people, how many of you are freaking out about doing these on your own? Yeah, a little bit, right? A little bit. Some of you are like, no, you're not freaking out. You just, it takes like a lot of steps, a lot of time. And some of you are like, yeah, a little bit, but no one's actually freaking out. It looks like that's good. All right. So Hilani says, and Naomi say, swap row 1 and row 2. And I would agree. Remember, our goal is to make this top left a 1, right? That's our first goal. So look, there's already a 1 here. So let's just swap row 1 and row 2. And that's what I did. Exactly what I did. I don't know if I can't remember like where the module started to do their own little tangent of where I'm going to do, but I'm going to assume they did the same thing in step 1. All right, so next, I want to make everything below that a 0. And it's kind of, so let's focus on row number 2. What operation should I do to make this a 0? So remember, we're going to use this row 1, right? We're going to use this to combine it with row 2 and row 3 in separate operations to make those a 0. So what do we all think? Just a random question: will there ever be any operations with the columns? No, there will be no operations when doing just columns. No, we can't do that. Those are invalid operations. So negative 2. So not quite, Naomi. You're on the right track though. So what about negative 2 times row 1, then add to row 2? Would that make that row 2, column 1 a 0? That element? Yeah. Right. And I didn't show my work this time. I just to save space, right? So we did negative 2 times 1 is negative 2 plus 2 is 0. Negative 2 times negative 2 is positive 4. Positive 4 plus 3 is 7. Negative 2 times 1 is negative 2. Negative 2 plus negative 1 is negative 3. Negative 2 times 1 is negative 2. Negative 2 plus 4 is positive 2. All right, that's how we got that row. Okay, so that's a 0. So how do I make this a 0? What's the operation that we're going to do? Negative 3 times row 1 plus row 3. I would agree with you. Yeah. So do you see how easy it is to make everything below this one is zero by using, we're using row one to multiply it by the opposite of, that start of row two, right? So that'd be a negative two. And to make that, we're going to use opposite of that, which is negative three times that row one. So you can see how these are very similar, and that's why we want to make this a one, because we're going to use this row, multiply some scaling factor to add it to the row we're going to change. All right, so now we're here. All right, now what are we going to do? Ideas. Yeah, so we want to make a sub 2 2 a 1. How do we do that? So row 2, column 2, we want to make this element a 1. How do we do that? Sorry, how do we do that? How do we make that 7 into a 1? So one way we can do it is multiply the entire row by 1 over 7. You are correct. We could do that. It would not be wrong. But now we're dealing with fractions, right? And that's okay. We can deal with fractions. Nothing wrong with it. I like to try to avoid fractions if I can. But yeah, multiplying the entire row 2 by 1 over 7 works just fine, just so you know. Anybody see something else we can do? Anybody else? Anybody else? Now, if I say it, I'm like, oh yeah, why didn't I see that? So 3 times row 1 plus, yeah, you just can't do that. That's not a valid operation. 3 times row 1 plus row 2. Yeah, that would, well, no, because then look what you get. If you did 3 times row 1, you get 3 times 1 is 3, and then 3 plus 0 is 3. So now we're changing this 0 to a 3. Yeah, you don't want to do that. That wouldn't work. Now you're creating more work. So it looks like the only, I guess, obvious choice is multiply this entire row by 1 over 7, and that would work. But now we're going to have fractions, which is fine. But this is what I did. Look at this. Look at this 8 and the 7. Couldn't I just do row 3 minus row 2? Isn't 8 minus 7 1? Isn't 0 minus 0 still 0? Couldn't I have done that instead? Yeah, row 3 minus row 2. Maybe not so obvious. Like multiplying it by 1 over 7 would have worked also, but now we have fractions, like I said. Doing it this way, we make it a 1, and we don't have fractions. We also don't want to disturb this 0, right? So like let's say that was a 1 here, and saying 1 minus 0, we would have made that a negative 1. So if that was anything other than a 0, this wouldn't have worked. But yeah, so 0 minus 0 is 0, 8 minus 7 is 1, negative 5 minus negative 3 is, well, whatever that is, right? Okay, next we are going to use this one, and we're going to make the stuff above it and the stuff below it a 0. So just to save time, we only have a few minutes left. Multiply row 2 by a 2 and then add it to row 1, right? We can see that. That'll make the number above it a 0, right? And then we're going to multiply row 2 by -8 and add to row 3. That makes that a 0. So now look at this. We got a 1 here. We got zeros. We got a 1 here. We got a 0 and a 0. So now we need to make this a 1. All right. So, I think the really obvious one is multiply this entire row by 1 over 11. And in doing that, we don't have fractions because 1 over 11 times 33 is still, well, an integer, right? Oops. All right, now we're going to use this one to make everything above it a 0. So multiply this row 3 by the opposite of this, which is 2, and then add it to row 2. So I can't remember if I did row 1 or row 2 first. I did row 2 first. Okay, so yeah, 2 times row 3 plus row 2 makes that element a 0 like we want it to. And then we do row 3 times the opposite of -3. So multiply it times 3, add it to row 1. That'll make that a 0. And look, we now are down to diagonals. 1. We got zeros in this column. We got zeros in this column. And we have zeros in this column. So this is an RREF form. So X is 2, Y is -1, Z is -3. So the ordered triplet answer would look like that. Oops, would look like that. And we could plug those into the original problem to make sure it works, and they do. So it looks like we solved this problem in 1, 2, 3, 4, 5, 6, 7, 8, 9 row operations. And I think your TGA, you can probably solve that problem also in 9 row operations, if what I remember correctly from last year. But these just take practice. That's why, guys, you need to spend time in the learn and practice. So the learn and practice modules. Work out every problem. Don't just look at what they do. You need to work it out for yourself because, like I said, this is taken directly from the learn module, but I approached it a lot different than what they did. So what I did, I think, makes more sense of their approach, but you can, read through their work and kind of decide that for yourself. So you just got to be creative, guys. This is pre-calc. You have to really think for yourself in this class. Not just for like this lesson, but for a lot of lessons that we do later this unit and this semester, and especially next semester. This is, like I said, this is not an easy class. So if you expected pre-calc to be easy like your past math courses, well, surprise, it's not. And you just can't use ways of like typing this into Google or using photo math. There's limitations, and you'll discover people who kind of swindle their way through math classes. You're probably in the wrong math class. So if you're someone who didn't do their own work in previous math classes, you might want to switch classes, honestly, because cheating your way through pre-calc is not that easy. So but guys, practice these. All right, it's about that time. We're over time, actually, but thanks for coming, everyone. And as always, I hope you learned something. I will see you all tomorrow.